prelude as PF Mac folder. No, I got it.
Okay, that's good. You're on. All right, so we're on to a new type today. Away from the optional, onto the list.
Okay.
And if we saw, I think, if I'll pump this up a little bit, we saw for optional, right? We said, all right, we know that optional A is empty or full of A, right? And all empty says is, I just want to represent the idea of there being one or nothing. Whereas list is like saying, okay, one or nothing is a bit restrictive. How about none, one or more? So list is really the idea of like, I want there to be an unbounded number of things, not just none or one. I can have none, I can have one, I can have 15, I can have a billion, I can have an infinite number. There's no bound. And so like you can see here that if you think about what are the values for optional, if I told you I had an optional of int, you could say, well, I can have empty, or I can have full of 10, or full of 20, or full of 30. Like these are all values, but they're all concept of like I have one full of 10. I don't have like 10, 10, 10, 10, or 20, 20, 20, or I can't have, a full of 10, 20, 30. It's like you got one thing in that full, that's it. And so we basically need a way to go, how do we represent this idea of like multiplicity, like having more than just 0 or 1? And this is where like, so now we kind of move from the world of just, very simple sum types to like using recursion to define our types. So what we really want to say is that a list of A, right, is nil, which is just like empty. It's just there's nothing here. Or
and Cam, could we call it null or?
Yeah, you can call whatever you want. Like banana's not here.
Like that.
Yeah, you could do banana's not here, and then we could say, but if it's not the case that there is something, we could say A, right, and then we can say, well, think about this. We could say cons A with a list of A. Now, what we're saying here is that it's either that the bananas aren't here, or you give me an A, and then you give me like the rest of the list, and I'll like combine those together.
Yeah.
Define cons?
What's that?
Yeah.
We've got to define cons.
No, this is the weird thing. That is cons is the definition of give me an A and a list of A. That's like.
Hang on. Is cons a Haskell term, or is it like?
No, this could be like join all the things.
Or what's the Haskell var for that?
So for Haskell, it would be, it's a little bit weird, but it looks like this. A list of A. Yeah, Dave?
Yeah.
I was just going to suggest maybe for myself, like if I have to refer back to this, could we like make the concepts consistent in that data, in that type constructor, like call it banana list and make empty no bananas, and then the other one like join bananas or a bunch.
This is like
bunch.
Head banana. Yeah. Or you could say like head with rest. A.
Yeah.
Or you could say maybe better. Oh, actually, banana with bunch.
And then banana A in the last.
You can think of this.
I mean, banana list A.
Yeah.
Sorry, the next. Is that right?
Yeah, that's right. So here we're saying either there's no bananas, or you give me a banana, which is A, or so you give me something of type A, right? And then give me the rest of the list, like the tail of the list, if you like.
Yeah.
So So in Haskell, it looks like this. Data, brackets A is empty, or it's A cons a list of A. Now, there's all type of wizardry going on. Like if I look at, if I say, hey, how is it defined in Haskell? That's how it's defined, right? It says, hey, it's just some type spelled open bracket, close bracket of some generic type A, and the value constructors, the values in the type are the empty list, or it's some element A cons with the rest of the list.
Cons is like concatenate?
Yeah, I don't even know where cons comes from, but I think it's not really concatenate. What's that?
Isn't it construct? I thought it was construct.
Yeah,
Like
that's probably
yeah.
No, that's probably spot on.
Yeah.
That's I can tell you've read the 98 paper.
No, that was from the Lisp stuff that I was reading.
Yeah, that would make a lot of sense. So this is really weird, right? Because if you say, what's the type of open bracket and square bracket, it says, well, that's just like a list of A. You're like, okay, cool. So that's just saying, it's just like if we said, what's the type of empty, it says it's an optional A, right? It just says, that's just a value of the type list of A, just like empty is an optional, type is a value of the type optional A. But you can also, because it's defined on the left-hand side of the equals, it's also a type constructor. So it's both, like depending on the context, it could be a type constructor or a value constructor, which is the kind of why it's not super clear when, like defined by Haskell, it's not super clear, whereas when we define it, you kind of have a bit more of a, like you can kind of tell what the two different options are. It's either, no bananas is a value constructor, bananas with bunches is a value constructor, but banana list is a type constructor. Like there is no type banana list, but there's a banana list of int or a banana list of float.
Yeah.
So
and is that because, so you don't have to, your data type and your data constructor can have the same name in Haskell. It's not illegal.
Yeah, no, exactly. Like you could say banana list here if you wanted.
Yeah.
Usually if you've just got, like if you've got one value constructor and one data constructor, usually it'd be the same. If I had like, I don't know, fave color equals fave color, fave color red. Like when you just got one type constructor and one value constructor, you just use the same name because you're just like, there's only one value in this type. Now, I think maybe a better way to go about it would be to say, how could we like construct a list? Like with an optional we saw, you could just say, okay, I got empty. I could call empty. I could call the value constructor empty, and I could get something of type optional A, or I could call the value constructor full with a value, and I can get something of optional int in that case, right? But how would I construct a list? Like what's the mechanism? What's the syntax for saying like I want to like build a list of things? And so let's say in our kind of other definition, list of A is nil, or what do we say? Cons A list of A.
Mm-hmm.
Right? If we look, we've got two value constructors, right? So nil here is a value constructor. It says it's a function where if you give me no arguments, I give you something of type list of A. And then we have the other value constructor, which is cons, which says I take two arguments. I take something of type A and something of type list of A, and I give you back something of type list of A. So if I wanted a list of say like 1, 2, 3, to build that list using this data, this type definition, I'd have to say, well, what's interesting is that it's recursive. And it's even better than recursive, right? Because you can have recursive types that don't have a base case. But if it has a base case, it's called like an inductive type. So the idea is that if you give me a base case, like if I just said that, That means you've got one value constructor that takes an A and a list of A. You could never stop. Like you could never get out of that recursion because there's no base case.
Mm-hmm.
But if you're chucking it and some other value constructor that doesn't recurse, then you can always use that as like the last one to plug in for this side. So let's say you want to list 1, 2, 3. So we might say, okay, cons 1. So here A is going to be 1. And now we need the list of A, right? But we can say cons, to construct something of list A, we can use cons and say 2. But then it's like, oh, okay, cool. You've given me 2 for A, but I need a list. And it's like, oh, okay, I need a list. All right, well, I guess I can do cons again, cons 3. And then it's like, well, you need to give me a list for the second argument. And you're like, oh, well, I don't want to do cons again, right? I want to stop here. So I can give nil as the value for a list. And then we wrap that up. That would be a list 1, 2, 3. And you can always think of like, that's the head. That's the head. Can I even vim? That's the head, and nah. Third time, no good. What am I trying to do?
Small v, not capital V. Yeah.
To the end. It's like that's the tail, and you're like, okay, for this list, that's the head, that's the tail. Oh.
Huh. So all lists are like trees.
Basically, yeah.
Without branches.
You can think of it like that, or you can think of it like a linked list where it's like you've got the element and then like the pointer to the rest of the list.
Okay, I see.
And all you know locally is like, I know there's a thing for the head and I know there's a thing for the rest. But like that's how you can kind of get this idea of multiple things. Because we didn't have any recursion for optional, like you've only got 2 options. You've got empty or full, like to call to get a value of optional A. Whereas lists, because it's recursive, you can kind of use the values constructed as part of the definition. So how do we feel about recursion? This is recursive.
So that's why when in native Haskell, if you use that built-in array, what you're always doing is you start with an empty array and then you concatenate onto that.
That's a really good point, right? So the equivalent in Haskell would be 1, right? Cons, 2, cons, 3, cons, the empty list.
Yeah.
And we could do a similar thing by using cons in infix notation, say 1 cons, 2 cons, 3 cons, nil. And we know that implicitly it's right associative, so it's going to bind like that first. Just like this is really going to do this, and then it's going to put 3 in there, and then it's going to bind there, and it's going to chuck 2 in there.
Yep.
And then lastly, it's going to take 1 and chuck 1 in there and get rid of that.
Yeah, okay.
So that's a really good point. That like whenever you see 1, 2, 3, 4, right? When you write like a list literal, Haskell just desugars that to 1, cons, 2, cons, 3, cons, 4, cons, empty. Like these 2 things are like they're the same.
Yeah. Okay.
So if we leave kind of that definition, the definition that they've given us is this one. So it's a list of A. We've got still nil as this kind of base case, but we've got T, and we're still using cons, but they've just spelt it differently. They've spelt it as colon, and you can see what they've done. If in normal Haskell you would do that, we've just defined it such that you can do.
Oh, that's an infix. It's like an infix function that they've written. It's not some built-in operator.
No, exactly. Like it's weird because you can give like at the end of the day, this is just like
Yeah, I gotcha.
you know what I mean? Like,
It could have
this
been
is
like a colon apostrophe. If we
yeah,
want.
it could have been that, could be whatever.
Okay.
Like you just because that's going to be a value constructor, and we just use an infix place here instead of prefix. Like you could have also said, and that's equivalent.
Okay.
Okay, is the idea here with this exercise to do the same thing? Work out all the cases for, as in like you get a nil. What's the return type? To stuff. The same thing we're doing with the optionals.
So some of the problems are like, how do we implement head or taking the product of a list of ints or the sum of a list of ints.
Oh, right.
So yeah.
So is this the? I'm sorry. So go ahead.
No, Dave, go.
So is this the? This is the. I think this is kind of the first time I'm seeing it. But is this like the format of the exercises in the course? Like you've got to start. You build the concept of a list type, and then you like implement all the way to map it or test it or add it or whatever.
Basically, yeah. So it's like almost like imagine we're back in '98 and we're like, oh, okay, we think we're going to implement this thing called Haskell, and so like it's our job to go through and implement the standard lib is basically what we're doing right now. We're going to go and define like the list type, and then we're going to implement like a bunch of helper methods or helper functions for working with lists, and then you might implement like how to map a list and filter a list.
Okay, I see.
So yeah, we're volunteeringly re-implementing the standard lib, getting not a dime.
Yeah. Okay, I get you.
So
it's massive.
It's a massive undertaking. Why would we do it for free? Only God knows.
So fucking massive. Have you seen how many files there are?
They're just outsourcing implementing Haskell.
Sorry to take us off track again. I've done it a few times, but how long would it take, say, yourself to work through the entire course, do you think, in hours?
Well, the guy that there was this one guy at Atlassian, Vito knows him, who I think he didn't go through the whole course. I checked. He went through probably like half of the course in 6 hours on like a live stream.
Oh, okay. Okay, so it's not like months of work if you're familiar.
It's kind of like I feel like there's probably like a handful of like really core ideas you have to kind of really get fluent with, and then after that you can just start going like bang 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 kind of thing.
Okay.
But caveat to that is that the person that Cam is referring to is probably in the top 10 most famous functional programmers in Australia.
Already.
Is that?
And maybe you could say top 100 in the world. He's like a pretty well-known functional demigod. Okay. So it might take a mere mortal a little bit longer.
Yeah, I don't know what the multiplier is on those 6 hours, but I mean they run I think because it's funny, they have like a short tracked version of the course that you can do over 2 days. The idea is you could teach it in 2 days. So it might be worth I think the reality is that we'll probably just start picking and choosing things that we think are like most relevant to going through the course.
Well, I think what's quite interesting is if you think about the course that we did at Data 61 and how, which I know isn't this, but the same kind of idea.
This is it. This is the same course.
Right. Well, the thing about that is there are people that had redone, people that that was like their 4th, 5th,
yeah.
It's like you never really, I think unless you get it, it's constantly dropping out of your brain. Yeah. You need to go back into class and get it shoved back into your to your ears. Otherwise, it falls back out again. Okay, I've cracked it. Okay, see you later. I've got functional programming. It's like anything. Constantly got to work at it.
I thought there's some real entropy when it comes to functional programming.
Exactly. Yeah, totally. And it's like the longer it takes to come in, the quicker it comes out.
Yeah, I know. Because I feel like if you don't work with it every day, it's just so easy to like lose that
And
touch
it's hard
again.
to work with it every day, right? Because it's not something that we commonly would use professionally, so it is hard to do every day, I guess.
Yeah, there's less opportunities for sure to work with FP languages.
Anyway, sorry, I took us off.
That's
Just
a good point. You're just trying to have some hope that we can get through this course. We're just thinking, come on.
I'm just having this. Yeah, at the moment, my hope is just to be able to get to the start line, which I'm getting there. But
I think you've got it. So
nice
like,
to watch you guys running.
I think this is kind of like this is because if I get rid of that, right, and I reload this, right, nothing's different. If we look at the list T, right, you could say, well, what's the type of nil? And nil says, look, I'm a function. I take no arguments, and I give you something of type list T. So that means that nil is of the type list int. It's of the type list float.
Yeah.
Right? Oh, not float. Double. What about bool? So I mean, it's of all type T's because it's in every type.
It's a generic.
Well, it's more like null in kind of OO languages. It's kind of it's a value of every type list T.
But isn't T the generic of list?
Yeah,
list
exactly. But like, yeah, so you can kind of replace T with whatever you want, and it would still be a value in that type.
And is that what we call a type class? List is a type class, or is list a type?
List is just a type. Actually,
okay.
To be specific, list is
a constructor.
Is a type constructor, yeah.
Sorry, yes.
So
because the T there is not a type. The T there is that it represents the value that you're going to give to list.
Well, actually, so yeah, I mean, you're spot on. Like it's the value you're going to pass to list, but because list is a type constructor, T will be the value will be a type. Like it's kind of like a higher order, right? Because now we're talking about
higher order type.
It's kind of what it is. It's like the type, the type function takes a type and returns a type.
Yeah. So it's a function for creating types.
Exactly. Just like cons is a function for creating values of some type.
Yeah. Yes. I gotcha. Yeah. Okay, so type class is actually just something else.
Type class is like a constraint. It says, you want to be part of this type class. Say list of T. If you want to be part of this type class, you need to implement these functions.
Okay.
So we looked at nil, right? And so we have a sum type, right? List is either nil or it's cons of something and like some value and the rest of the list. And so we can ask, well, what's the type of cons, right? Weird looking, but like if you just think of this as just a function, like any other function, it's just like map, right? It's a name for a function and it has a type, and its type is I take something of type T and I take two arguments, something of type T, something of type list T, and I give you back something of like type list T. So it give me a value, give me a list, I'll put it onto the end of onto the front of the list, and I'll give you back that list.
I might do that. It doesn't say the type definition doesn't say that it's going to give you back the sum.
No, exactly.
It's going to
Exactly. Like that's a really good point. Like nothing in this type says that I'll give you that back.
I might remove the list, or
I might give you back the empty list every time.
Yeah.
Still would type check. It's like, you give me T, you give me list of T, but I give you back the empty list. It's type. It's like that's correct from the compiler, but it's not the function we wanted to implement. It doesn't have the behavior that we want.
And when it comes to the type class, you said, sorry, I'm kind of trying to back a little bit. You said that a type class is a type is a member of a type class if it implements certain functions, which I guess is a bit like duck typing, right?
A little bit. It's like duck typing in a sense, but the compiler will tell you if you get it wrong. So if I try and call some function, it says, hang on, this type doesn't implement this function, so you can't use it.
And the definition, when you define a type class, do you just put type signatures there, or do you say like it needs to have a function called plus, which takes an int and returns an int?
So for example,
is that all you do, or do you like say what the actual body of the function is?
Well, this is one here, right? So there's a type class called show, which says you just have to tell me how the hell do I get this thing into a string? You've got some type. What do I? Right? You give me a little type of a veto type, and you say, how do you give me a string for veto? Right? How do you do it? How do you take the man who is veto and give me a string? So you would say, I have a type class show of a, where you have to implement this one function.
Okay, and it's just a type signature. It doesn't say anything about the implementation details.
Just as when I call you, you give me a string. That's all I need.
Yeah. Okay, cool. Awesome.
So
Thanks.
That's kind of like and so you can see from this that we can build like using this trick of 1, 2, nil, we can build lists of any, length we want. And we could say nil has 0 length, and 1 nil has length 1.
And can you how would you tell what the type of that is? Like, you go put it in bracket? Oh, you just do it like that.
Really gone. So here it says, says you've got a list of t, where t is in the type class num.
Yes. Did it just infer that, or that's defined somewhere? They've already defined that somewhere.
Well, what's happened? I mean, there's a type class called num, which just says you have to implement all these things. But what it's doing, it's saying it's saying like I don't know if 1's an int. 1 could be a float or a double, or it could represent something else. So I'm just going to say that the constraint is that it must be in the num type class, but I'm not going to say what instance it needs to be.
Okay, cool.
That's
great. Thank you.
Because if you say like what's the type of 1, it says, well, we're just going to say it's in the type class num, but we're not going to tell you what instance it is. So that's kind of, we can kind of go as, we can kind of do this for as long as we want, basically forever, if we had the time to still be like, that, and then as long as it hits a nil at the end, it's fine. So this just says, I just want to make sure that this function, right, cons, just has it's right associative. So if we do 1, 2, nil, it's like, hey, that I need you to do that instead of
not that way around.
pointing to the left. Don't do that.
Is it by default from the left?
Yeah, I think by default, if you don't tell it, it'll do it by the left.
Okay.
And then you can do. What's that?
That little function, that infixer function. It's like a funny, like that's a Haskell thing.
That you can do infix functions.
No, like that infixer is that one you made up? That's like a keyword of the Haskell.
Yeah, exactly. It's a keyword. That's a keyword. It says, "Hey,
it's just a funny little
hey, get in that. Go to the right.
Like it drops
infixer. Infixer. Just fixing things. Hey, it was gonna be the wrong result.
Producer.
A little infixer. There's a in breaker as well.
All right, let's do it. So what are we creating first? What's our first function?
All right, so first one to get us going, we're going to implement head or. So head or says you give me some lists. Sorry, you give me an element, right? You give me a value that is the same type as the elements inside the list, and if the list is not empty, I'll give you the head, meaning the thing at the top of the list or the start of the list. But if the list is nil, I'll give you the default value. So it's like a default head. And you can just use it here like infix, right? So you can say X head or in infix with the infinite list. or X header with the empty list, and it gives you back X. So, all right, let's go. So we've got this function called header, takes an A.
Sorry.
You go.
What does that prop word mean on?
So that property. So there's a idea there's a very popular library called Quick Check in Haskell, and the idea is that you specify some property that you want to be true, and it will like run it on like a distribution of data and see if it can like prove you wrong. So he's saying like it's like for any arbitrary x, if I take x header infinity, I should get 0.
Okay, gotcha.
And it'll like go on crunch like thousands, millions of test cases to see if it can get you to fail.
Cool.
So we've got this header, right? And the type says A list of A returns an A. So let's kill that. Let's kill the error. We're going to take out 2 arguments.
The recording's going to end, I think.
Oh yeah, in a sec, are we?
So might need to read.
Jump back on for 10?
Yep.
Yeah, let's get it to 2.
Yeah, sounds good. All right. Well, maybe. Oh, wait, we'll just. We just wait for it to go.
How much time have you got left?
I think if we go out and back, if we close out and back in, it'll start again. Should we just do it now?
Yeah, let's just start then.
Okay. See you in a sec.
All right, sounds good. Look at that magic. It's like we never left. So, all right. So we've got this header, and I can just tell Vito knows how to solve this header. He's been waiting for this his whole life. So when we've got a function, right? Let's just get those arguments in the game. Let's just bind those arguments. So let's call A X, and now, okay. So I'm just going to put an underscore to say like we're going to put a value in there, but let's think about what the value could be. So you give me some X of type A. What should we replace this underscore with, right? We know it's of type list A, but we know in the case where the head is nil,
let's
we
do
want
that.
to return 3 in this example. So what? Let's handle the nil case first.
Nil.
So what should we replace underscore with? Bang. I'll take that.
Okay, yeah, I get you.
X.
And then what should we return? I could tell you were ready for this.
Peter, look at you go, man.
So you can look and go like, okay, look, how good's this, right? We've covered one case, which is we know that some value of type list T has to be nil or this other value, right? Has to be either constructed with nil or constructed with cons. So what's the other case? If it's not nil, what could it be?
Something that is a list.
All right. So like,
But
say it's a list. We know this list is of type list A, but we need to give back an A. The head of the list.
can we pattern match with L:/LS?
I'd love to hear it. So with something like XX's,
Yeah.
or maybe
Well, it can't be X though, right?
AA's.
Yeah.
Yeah. And then, all right, so now I've got, so literally here we've got the head, A is the head, AS's are the tail. So what should we return in this case?
Just the head A.
Bang. Look at that. That's
Is that
record. That's it. That's a record time.
What?
So it's, what have I done? Oh, sorry. It's
Yeah, that makes sense. I was thinking, I'm like, what the fuck is in you? But yeah, that makes sense. Yeah. Because you got cons.
Okay. Yeah.
So if I say,
You need the cons.
huh?
See, the reason I said, yeah, I didn't realize that, like, I'd seen that phrase before, like X:/X's. So I was like, oh, maybe it's that. I saw that in the book, but it never occurred to me that that's just cons. It's just looking for
It's just a definition of
where that function sits in the middle.
Exactly. It's literally just looking for how do you construct it.
Wow.
So you always kind of know that you can do this, that at some point in the past, someone did that.
But hang on a second.
Like do you know what I mean?
We're passing head off for X and a list of A. We return A. What the fuck is AS?
Oh, AS is just a name we gave to the rest, right? So
right.
in the case
it's like doing ...
Well, yeah, I mean, semantically it's the same. Does the same. It's the same kind of idea, but really,
it's going to recursively go over AS, right? So is it?
Well, no, it's literally just like it's just like a reference to the rest of the list. Because if you think about when you constructed, like you can think of cons, if we call it in prefix, is give me some value 2 and then give me the rest of the list, right? And I'll combine them together. So this is just kind of like undoing it once, just saying, just pull the head out just once and give me the handle to the rest of the list.
Of course, because we need to return A, so we need to get the first thing out of the list. Yeah, okay, totally. Yeah, gotcha.
And here you could say, I don't care about the rest.
And can you put spaces around the concat infix function name there?
If you want.
So that will still work.
Yeah, that's fine. I mean, just like I can say 1 and nil will just give me 1 and nil, or I can say 1 nil.
Yeah. Okay. Well, I don't know why all the examples I've seen don't just start off by putting spaces there so that you know that
they're separate things.
Yeah, it's like I thought this colon was some special notation that's like, I don't know. I mean, it is.
I don't think there's the only special notate, like any special thing that Haskell has is this list syntax where it's like brackets can be both a type and a value. Apart from that, like everything, if you see some weird looking thing, it's just a function that has a name that you can.
Can I ask, just like I know it's not like it's not a closure, but the underscore on the left, like on the left-hand side of the equation, like that underscore, those two underscores represent different things, right? But they're both throwaway. They're both throwaway, so we don't care about it.
Yeah, exactly. So this just says, don't give me a name. Like I could say X
totally.
and I could say A's, right? And then if I put a hole there, it would say, I found a hole, and that hole needs to be of type A. And in scope, you've got AS's, which is a list of A. You've got some name A, which is of type A, and you've got some name X, which is of A, right? And so it's like, what do you want to put here? Now,
so hole is an actual thing. Like, can you use multiple underscores in the same expression?
On the right-hand side of the equation. So you're here saying, I don't know what to put there. I'm just going to put a hole, and then I'm going to get the compiler to tell me what it thinks it should go there.
Because it's kind of like a close.
But
like the inside that bracket there, it's it's not a close. Like it doesn't give a fuck at all. It's kind of weird.
No, it just says like it just takes what you had. If you had lists, right? It takes that and it says, I've got a list, but I know that list was constructed with either nil or cons. And if it was constructed with cons, then I can just replace it with, let's just call it like element and elements, right? And it goes, I know I can do that because it's not nil, so it must have been constructed at some point, and so then I can just replace it with the head and the rest, right? Like if you think about it in reverse, at some point someone passed this element to a list of L's and constructed them together and cons them together. Like,
it's like a capture group in regular expressions.
No,
Is it?
No, it's more like what it's saying is that if I had a list here, right? If it knows it's not nil, right? Because it tries to match this first and says that ain't nil. So I can't match nil. So then it looks up at the definition and it says, okay, well, it goes, if this is the definition, it's not nil, so it has to be this thing on the right hand side.
Okay,
And so
I see. Okay, I see.
It literally just literally just substitutes it and goes, well, I'll just substitute my list on the left hand side for the constructor on the right hand side, and so T will become, I can say T, and then it's cons with the
and
rest
then
of
you can hole it, or you can like underscore it, because the right hand side of the equation doesn't give a fuck. It doesn't give a fuck about X. It doesn't give a fuck about TS. In this case, all it cares about is T. We just want to return the head back.
Exactly. Because
is that valid?
That's valid, because all you're saying here is don't create like a name for this thing, so that when I put a hole in,
knows that underscore. It's not underscore is not a name. It's a non-name.
No. So in this case, right, if I put a hole and I say, I reload this, it says, oh cool, I found this hole called underscore to do, and it says it's of type A, but look how the relevant bindings is T. It didn't tell you what else was there because you said I don't care about it. So it means this is a lot easier, because if you just follow the types, like here you could literally just go, I need to fill this hole with something of type A. What's in scope? I know T's or type A. Well, it has to be T. There's like no other thing it could be.
Cool. A hole. So the hole is a concept. It's not just a naming convention.
Yeah, when you're on the right-hand side of an equation, like you can't say to do here. That doesn't. Now you're just giving it a name, underscore to do.
Yeah.
But on this side, you're saying, I don't know what to put here. Can you like give me a helping hand?
Okay, one last question.
3 o'clock. It's 2 o'clock.
No, wait. Shit. Is there any? What's the reason for that someone called it T? I mean, I know it's arbitrary, but why T?
Well, it's I don't see. In this definition, we called the polymorphic type, like the type variable is T. It's just convention. Most people would say X and X's.
Yeah,
that's what I'm saying. That you just say, but it doesn't matter what you could. I mean, or some people will just look at the type, and if the type here is A, they might say it's A's and A's.
Yeah. Okay.
But it's completely arbitrary. You could say head and rest.
Yeah. And then just return the head. Yep. Yeah. Cool. Yeah, I think a lot of what makes it hard is to learn is the tendency for people to write it so tersely.
Yeah, I know. Like there's so much.
I don't want to call my variable a name that someone will understand. I want to use a letter.
Look at this. This is how they've implemented fold right. It's just like F, B, H.
Yeah. Which I get. Once you know enough, you're like, oh, that's cool. I understand. But you could write it in English, and it would be probably
be super. Like this would be like for fold left, you'd be saying like, all right, I got a function here, so I guess this is the other part too that makes naming even like harder in Haskell is that like you're not usually talking about performing some operation to some like concrete thing. You're more talking about like more abstract transformation. So it's like, what do you even call that thing?
Yeah, what do you call it? Saying like function data value.
Yeah, like you say like func from B to A, and it's like, well, the type tells you that, so like you know what I mean. So yeah, I think it's a little bit more awkward with naming.
Anyway, that's all good. Okay, thanks.
So that's this is great, and this would even work for we have this infinite list, right? We have a list of integers which is infinite, and if I go infinity, I need to clear that hole. Maybe it's just a teaser for next week. If I say infinity, boom, look at that, it prints into infinity. like that disco, bit of oh.
I really
Enjoying that?
like our const symbol.
Okay,
It's cute. Like there's a lot of hate.
So
There's a lot of hate on the terseness,
Like a crying.
but I like the I don't mind the terseness with the functions having these cool little symbols.
So
Yeah, I like it now.
I know the cons.
Hard to make. Yeah, I like it now too. But at first I was like,
it definitely is hard to know when you look at it like a tutorial or look at code. Look at Haskell code on GitHub, and you're like, I don't know what is standard lib and what is.
Yeah, and they're doing like, well, it's like this, and you've got you're applying that over some, put it into this map here, back there. It's like looking at like a Unix shell. But here's one I'll leave you with, right? So I just showed you the infinite list, right? And we all believe that it goes on for infinity.
Correct.
So what's head or? Give me a favorite number, Dave.
7.
Oh, yeah, it's my favorite. Now, if I've got the infinite list, what should this return?
Oh.
An infinite list starts at 0.
It should just return.
So,
in and infinity are two separate things. So it's to split out the head of in and return that.
So I've got one.
No, it should return 0.
All right, head or 7
instantly. Because Haskell's lazy.
That's it, 0. Now,
made in heaven.
That is like. That doesn't seem like.
Or towards heaven.
Now, like, there's this, like, it's a shame we're out of time in the sense that the next thing we have to do is take the product and the sum of a list. And to do that, we've got to use fold right, this function called fold right, like folding over a list. But there's a way to implement head or using fold right over an infinite list. And that's just like how that works completely changes how you think about programs evaluating.
Okay,
if you look at it,
next week. I'm ready to get my mind blown in a week.
This is a good amount, Cam. I was like, that was awesome. I was like, yeah.
That was great, man.
I followed it.
I think maybe what I'll do is in between now and then, because I kind of jumped over this, where is it? Type class business. So, I mean, I know like we've spoken a little bit about type classes, Dave, but probably worth maybe the next one or after the next one, certainly because once we start getting into like the functor monad territory, that's all that is just type classes. So actually maybe I'll just wait till like once we finish the list and before we jump into functor.
I mean, that'd be good for me if you guys don't mind going at that pace, but yeah.
No, that works for me.
Okay. Are you doing like, are we following you doing this course for uni? Is that what we're doing? Or are we going like in parallel?
So I'm like, this is just off the side of what I was doing with my course. But my course is it's not a Haskell course per se, but the main language is Haskell for what they're trying to teach.
Okay, but we're not like holding up your studies.
No, it's not like I've got to I need to be done by list next week. No, it's not like that.
Okay, good. Okay, cool. Awesome. All right, well then, yeah, this is good dose, I feel like, for me.
Look, a nice little, I've got the list. That was the main thing. I've got kind of handle on list. You know how to implement head or. Like next week's going to be, hopefully next week it'll be like this whole thing of like reducing on infinite lists. That's like where you can get a lot of fun out of it.
I really like this lesson because it caps off a really good week at Pickett. A really good week.
Yes. Except for one really bad.
In the scheme of things, as part of the larger project, it's insignificant, small. But we had MMP went out to the update. It's usually been 10 months in the making. I'm not exaggerating. 10 months in the making for an update. Got out to the iOS store and the Android store, and it looks like it's working from the test that I've done. That's massive. We sent out our first newsletter. Cam, I'm sure you got that. We sent that this week. That's been a big project that's been a long time in the making. And I've been trying to learn Haskell for fucking 5 years, and now I have. Yeah, I've got it. I'm going to be taking the next class. So that's wonderful.
I didn't realize that you'd been
I did the thing and I got burnt out. I didn't touch it, but like I always wanted to I didn't want to give up on it, and now we're back. So it's awesome.
Yeah,
thanks, Cam.
Thanks so much,
Thank
guys.
You. All right, well, have a good weekend, and I'll
you
see
too.
you guys next week.
Awesome.
All right, see ya.